In this video, we're going to be looking at representing and analysing data. One of the challenges students face in science is how to represent and analyse data. We're shown data on the television, newspapers and the internet all the time. As teachers, we're to prepare our students to work scientifically in the wider world and to be able to make sense of the data that they're shown. It's therefore important to emphasise to students that data is not just for science lessons exclusively, and that the analysis of data is required in most subjects, workplaces and life events. The skills that they're learning with you in the classroom can be applied throughout their lives. Working scientifically involves testing a hypothesis, collecting results and analysing these results to write a conclusion. In this video, we'll be looking at how students can represent and analyse data. Many science lessons involve students testing a hypothesis. Students may work in groups to collect data and record results in a table. When plotting a table, some students may require support when drawing their own tables to log results. Remember to tell the students that they will need one column for the independent variable, up to 3 columns for the dependent variable, as they may be making 3 sets of measurements, and another column for averages, or sometimes called the mean. Students should remember to put the unit at the top of the column. Data can be represented by the use of charts, tables and graphs. Have a pre-made graph axes if it's a student's first few times drawing a graph. This is so you can refer back to how a graph is correctly drawn. Students tend to make small errors when plotting graphs, which will affect their grades in summative assessments. Some of the common errors when representing data on graphs include the following: not labelling the axes at all and forgetting to put the units on the axes, drawing an incorrect chart, for example drawing a line graph when it should be a bar chart, or some students use an incorrect scale, and connecting the points like dot to dot instead of doing a line of best fit. Emphasise the correct fashion of drawing a graph, as this skill is assessed in Key Stage 4 and 5 examinations. Interpreting results equally has its own difficulty. Students seem to struggle with how to analyse the results they've taken, especially when it comes to looking at relationships in graphs and being able to state what happens when one variable changes and what happens to the other. Start with some simpler examples at the beginning of the lesson. Perhaps choose variables that are more relatable to students. Draw a graph showing the time spent in a gym against muscle mass, or plot a graph of time worked against amount of money earned, and get students to practice describing the relationships between the variables. Once students understand the concept of relationships in graphs, they should be able to apply this knowledge to different examples. One type of graph that students particularly struggle to interpret are distance time graphs, especially if the gradient is curved. Students get confused thinking the object's speed is increasing when the gradient is a straight line and not travelling at a constant speed. This becomes more challenging when students are introduced to velocity time graphs, when a straight line means something completely different. Practice is key when learning to represent and analyse data. It's a skill that needs to be developed over all the key stages. For a reflective question, how can wall displays and poster displays support students in their analysing and representation of data?